Okay, I'm really sorry about that. There was a glitch. Let me know if you guys can hear me. And hello and assalamu alaikum, everyone. Can you guys hear me? Chain rule says samjhayega. Okay, Mustafa, just so you know, this is for IGCSE Math. It's not Add Maths. Okay, please, everyone should take a note of that. That this is not for IGCSE. This is not for Add Maths. Okay, this is for IGCSE Math. Okay, this is something that was recently added in the syllabus. Walaikum salam, Hadia. So yeah, that's what we're gonna do today. Okay, just a minute. I'm just gonna post on my Instagram that we're live, and then let's start. No, this is not A levels. This is IGCSE. Okay. A level students, yeah, they can benefit from it. I mean, if you want to learn the very basics, okay, the very basics of differentiation, then yes, of course, you can watch this and benefit from it. Yeah, of course, you can use it for maths also, and you can also use it for A level maths, and you can also use it for Add Maths. But don't expect that after this we will, you guys will be able to 100% solve questions from maths, A level maths or Add Maths. Okay. Anyway, so let's start. We were supposed to start at 6:30. Okay. Sorry about the delay on my side. I hope you guys, like I said one last time, I hope you guys can hear me loud and clear. Anyway, so let's start. So basically, it's a very easy topic, by the way. As far as no, this is not for 0607. In fact, you know what? I think I should just edit it and mention that it's 0580. Okay. So yeah, it's 0580 IGCSE Math. Okay. Now, so as far as the concepts are concerned, okay, just at a glance, if you look at the concepts, so the first concept is dy by dx, okay, actually differentiating, and then you have finding gradient, and this basically means that finding dy by dx given the value of x, then finding turning points and stationary points, then finding the nature of turning point or stationary point, and then finding the equation of tangent. Okay, so these are all the concepts that we have at a glance, okay, just like an overview. So we're going to do all the concepts in detail. By the way, you will find a folder in the description where I've uploaded this file. Okay, I will update this file once we're done with the live stream. Okay, so you can have all the notes that we take during the class. Okay, and there are also some past paper questions, okay, which I have compiled with the answers, which we're going to solve today only, inshallah. Okay, all right, so let's get to work. So the first concept is finding dy by dx. Okay, now before we dive into that, let's first do an introduction and see what differentiation really is, okay, and what's the whole purpose of studying this. Okay, so here's an introduction. Now quickly, I want a yes or no from you guys. Have you done graphs of functions? Okay, now that doesn't mean, I don't mean to ask as if you guys know that topic well or not. Okay, that's okay. But have you guys done graphs of functions? Yes or no? That's all I want to know. Must have done it in grade 10 or grade 9. Okay, so we have a yes. Now, in graphs of functions, the whole concept of studying graphs of functions was this. You were given a certain value of x, and using that value, you were then asked to find out the gradient of the graph at that particular point. Okay, so let's say here are two different values of x, okay, and you're supposed to find out, you're supposed to find out the gradient of the curve at these given values of x. Okay, so one way to do that would be to make a tangent. Okay, but this method was not too accurate, okay, as you would know that there would always be a range of acceptable answers, okay. So the other method and the more appropriate method is through differentiation, okay. So in short, basically the whole idea of differentiation is to find the gradient of the tangent on the curve at any value of x, okay. This is the primary objective and the primary purpose of doing this, okay. This, as you can see, is the objective, okay. All right, now, so the thing is, and then through this we will also find out the coordinates of the turning point, and through this we will also find out the nature of the turning point, okay. But remember, the whole purpose of studying differentiation is so that you can find out the gradient of the curve at any particular point, okay. But before we do that, we need to first learn how to differentiate, okay. So here's the first step, finding dy by dx, okay. Now, if you're given, let's first write down the general form and then we'll see how it works. If let's say you're given y is equals to ax to the power of n and you need to find out dy by dx. So here's how this works. In order to find out dy by dx, what you do is you multiply n and a together, okay, and then you reduce the power by 1, okay. So this is how you differentiate any power function, okay. So let's do a few examples. Let's say you have y is equals to 3x to the power 4, okay. So what do we do if I want to differentiate it? This is how it works. Dy by dx is equals to 3 into 4, that's 12x to the power of 3. There you go. 3x cubed, that's how you differentiate it. So that's one example. Let's do another example. Let's say you have y is equals to 15x to the power 3. How will you differentiate this? So dy by dx is equals to 15 times 3, which is 45, x to the power of 2. And that's it, 15x squared. That's your final answer. Okay. Now, anyone who can tell me the answer to this? Let's say you have y is equals to 3. How will we differentiate y equals to 3? A good way to start is to first think, what is the power on x? Even though there's no x, but like, what if there was? What would be the power? Yep, that is correct. The answer will be 0. So if you have y equals to 3 and if you differentiate it, dy by dx will actually be equal to 0, okay? And the reason behind that is that there's no power on x, so we can write it as x bar 0. And if you think about it, this makes sense also. This y equals to 3 is basically a horizontal line. This y equals to 3 is nothing but a horizontal line. And if you have a horizontal line, we know from prior knowledge, we should know from prior knowledge that a horizontal line has gradient 0. M, which is for gradient, is basically equal to 0, okay? All right, now, let's do a few examples, okay? I've written down a few examples over here, which we're going to solve. I've highlighted them also. So let's start from question number 1. So dy by dx for question number 1, let's write down the question also, which is 3x squared, and dy by dx is going to be equal to what? Dy by dx is going to be equal to 6x, and that's it. That's correct. Okay, number 5, we have y is equals to 4x to the power 4 minus 3x cubed plus 5x squared. So what will be dy by dx? 4 times 4 is 16, x cubed minus 3 times 3, which is 9x squared, plus 10x. There you go. Okay, now question number 9. Pay close attention to question number 9. Question number 9 is y is equals to 1 upon 5 x to the power 4 plus 3 upon 4 x cubed minus 2 upon 5 x squared. Okay. Sir, has the maths 4024 syllabus has not been updated. Okay, this is for IGCSE. Okay, you can see that the syllabus code here is 0580. Okay, so now let's differentiate this. So we're gonna have 4 upon 5, reduce the power by 1, that's x cubed, plus 3 into 3, that's 9, 9 upon 4, x squared, minus 4 upon 5, x. That's it. Okay, so in short, you multiply the power and the coefficient and you reduce the power by 1. Okay, so you can memorize it like this. Okay, now here's a trick question. Okay, how do we do this? Sir, please make a past paper video on A-level paper 1. Yeah, A-level paper 1 is on my list. I'll do a live stream on that also. Sir, is there derivatives and fractions there in 0580 syllabus? Yeah, there is. Okay, so how do we differentiate this? When will I upload A-level differentiation? Hopefully in December. Hopefully before mid-years. Okay. Either I'll upload it or I'll do a live stream. Okay, now let's solve this question. So basically, before you can differentiate this, what you do is you make this differentiation ready. Okay. So that's what I like to call it, is that you make a differentiation ready. And what do I mean by that? By making a differentiation ready, I basically mean writing the power on x in the numerator. Okay. So this is what I mean. This right here is differentiation ready. Okay, now we can differentiate it. So if I differentiate it now, dy by dx equals to 3x squared. And what will be the differential of minus 3? That's going to be 0. Okay, and let's see what we can do with this. So here, 8 and minus 2 get multiplied. So that's minus 16. And then you further take 1 away from the power. So minus 2 minus 1 is minus 3. Now let's see what dy by dx is equal to. Dy by dx is equals to 3x squared. So plus 0, we're just not going to write it. Minus 16x to the power minus 3. Now I would prefer to write it nicely, and when I say that, I mean let's make the power positive. So that means 3x squared minus 16 upon x cubed. There you go. That's it. That's the answer. Okay, so hopefully all is well so far. Now let's move on. Okay, now this concept is finding gradient. So technically, we are now done with finding dy by dx. Okay, now we're doing finding gradient. Okay, how do you find the gradient? See, if you're given the value of x, the whole idea of doing differentiation is that you can use any value of x, plug it in dy by dx, and find the gradient. Okay, so here's question number 1. And by the way, one thing that I want you guys to remember is that note, if you have, why do all math teachers prefer positive power? I don't know, it's just I don't know. Okay, I really don't have an answer to that. Okay, so if you have y and if you then differentiate it, so we call it dy by dx. Okay, but if you have f of x and if you then differentiate it, we write it as f prime of x. Okay, so the prime or the apostrophe, whatever you want to call it, is just to distinguish the equation of the curve from the gradient function. Okay, so remember what you see over here, this is something that's going to be referred to as the equation of the curve, equation of the curve, and this that you see over here is going to be referred to as the gradient function. Okay, so now let's do these example questions. It says find the gradient of the curve y equals to f of x when x is equal to 1. So we have f of x, which is equal to 2x squared minus 3x cubed. So here's how we do it. This is going to be done in 2 steps. First we differentiate it. First we differentiate the equation of the curve. So that means 4x minus 3 into 3 is 9x squared. Okay, and then you plug in the value of x, which is 1 in this case, to find out the gradient of the curve at that particular point. So 4 times 1 minus 9 into 1 squared. Let's see what do we get. So f prime of 1 is equals to 4 minus 9, which means minus 5. dy by dx, change in y over change in x. Yep, that's what it is. Change in y over change in x. So f prime of 1 is equals to minus 5. Okay, so remember dy by dx is basically nothing but change in y over change in x. Okay, it's like, you can think of it this way, that d stands for difference. Okay, difference in y over difference in x. Okay, all right, now let's quickly do part c also, so we see how that works. So f of x equals to 2x squared minus 3x cubed. And then f prime of x, we already have that, which is 4x minus 9x squared. Now let's find out f prime of minus 5. For this, I would strongly suggest that you use a calculator. Okay, so f prime of minus 5, let's see what this is equal to. 4 into minus 5 minus 9 into minus 5, the whole thing square. So we get minus 245. There you go. Okay. Now, moving on. Now, here's question number 6, which is slightly different from the previous two questions. Okay. Let's see what it says. It says, find the coordinates of the point on the curve y equals to 7 minus 3x minus 2x square, where the gradient is 5. Okay, so how is this question different from the previous question? That is, and just by the way, this was part A and this was part C. So in this particular question, we are given the gradient, and what do we have to do? We have to find the coordinates of the point. Okay, so let's see how this goes. So y is equals to 7 minus 3x minus 2x square. So the next thing we do is we differentiate it. So we have dy by dx, which is equal to 0 minus 3 minus 4x. Okay. Now what do we do next? Question for you guys. We have dy by dx, which is equal to minus 3 minus 4x. What is it that we're going to do next? Dy by dx is 5. That's correct. So what we do is we know the gradient, and we need to find out at what value of x is the gradient actually equal to 5. Okay, so that means we're going to set it equal to 5. So 8 equals minus 4x. Let's write this nicely. Minus 4x equals to 8. So x equals to what? X equals to minus 2. Okay, and there you go. That's it. That's your answer. Yep. All right, here's another question. Let's see what this says. It says the curve y equals to x cubed plus 2x squared minus 3x has a gradient of 4 at points A and B. Okay, so this question is slightly different in the sense that it's using the word points. What does that mean? And not only that, in fact, it's telling you that there are 2 points. Okay, so what are we going to do in this? In fact, before we do it, it's always a good idea to think slightly ahead of the question. So when I'm looking at this question, the first thing that I see is that it's used the word points. Okay, that means we're going to end up with more than one value of x. Okay, now the question here is very specific. It has told us already that you're going to end up with 2 different values of x. Okay, one of them is going to be the x coordinate of A, and the other will be the x coordinate of B. Okay, so here's what we do. We differentiate it, and one thing to also keep in mind is that if you're ending up with 2 different values of x or 2 values of x, it's because it's likely that you're solving a quadratic equation. Okay, so I want you to keep that in mind. The reason why we could end up with 2 different values of x, it's because we're very likely solving a quadratic equation. Okay, so let's see what the differential of this curve would be. So dy by dx is going to be 3x squared plus 4x minus 3. Now the next thing we do is we set this equal to 4. 3x squared plus 4x minus 3, because looking at the question, we can tell that dy by dx is actually equal to 4. So that means we set this equal to 4. Now we get everything on one side, 3x squared plus 4x minus 7 equal to 0. So now we solve this equation through middle term breaking. Okay, and I hope everyone knows how to do that. 3x squared plus 7x minus 3x minus 7 equals to 0. So we factor out x. Let's see, what do we get? We get 3x plus 7. And then we factor out minus 1, so we get 3x plus 7 equals to 0. Now, it's a good idea to check your answer using your calculator. Okay, I hope everyone knows how to solve this in their respective calculators. So we have x equals to 1, and then we have the other value of x, which is going to be minus 7 over 3. Okay, I've skipped a step there, but I'm sure you guys know what I've done. Okay, so I'm just going to quickly check the answer in the calculator. So 3, 4, minus 7. So 1 and minus 7 over 3. Yep, that's correct. And there you go. That's it. That's question 7 solved. Okay. Now, Here is finding turning point and nature of turning point. So for this, I would like you guys to pay close attention. Okay, that's because this is slightly tricky. Okay, only slightly. Now let's see how this works. So basically, at any curve, if the curve is turning, okay, so one thing that you guys keep in mind is this. At any point where the curve turns, what happens if you draw a tangent at that point? Okay, so if I were to draw a tangent at this particular point, if I were to draw a tangent at this particular point, let's call this x1. That means we're gonna have to call this x2. Okay, now let's see what happens if I draw a tangent at these 2 points. Working necessary for middle term? Yes, I would strongly suggest. Is this AddMath differentiation? Nope, it's not AddMath differentiation. It's IGCSE Math differentiation. However, AddMath students can still watch it and benefit from it. Okay. All right, now coming back to my question. What will be the tangent like if I were to draw a tangent at this point and this point? What is it going to look like? Anyone with the answer? Yes, this will definitely help you in A level. Okay, so I'll answer the question. So basically, if you were to make a tangent at a horizontal at this turning point, okay, it's going to be a horizontal line. Okay, so if you were to make a tangent at these 2 points, you will get a horizontal line. And if you're getting a horizontal line, remember that dy by dx equals to 0. Or in other words, the gradient, which is m, is equal to 0. Okay, because we know from prior knowledge that if you have a horizontal line has gradient 0. Okay, so that's one thing that you should remember, that at the turning point, gradient is equal to 0. Okay, so I'll write this down. At turning point, now we don't just call it the turning point, by the way, we also call it the stationary point. A turning point or stationary point, or even maximum or minimum point. Okay, remember dy by dx equals to 0. Okay, and why is that? That's because I've explained it right over here. This is why dy by dx will be equal to 0. Okay, so I'll just drag this down. Just a second. Yeah. Okay, so now the question is how to find the turning point. Okay, let's see how to find the turning point. Okay, and then we'll talk about how to find the nature of the turning point. And please remember, it's not just turning point, we also call it stationary point. Okay, so step 1 is that you find dy by dx. Okay, and that means that you differentiate the equation of the curve. Okay, so what's step 1? Step 1 is find dy by dx by differentiating the equation of the curve. Okay, then comes step 2, which is that you equate dy by dx to 0, or set dy by dx equal to 0, and find the value of x. Now, if you have the value of x, okay, and you still have to remember that your turning point, when we say point, we mean 2 coordinates, x coordinate and the y coordinate. Okay, so if you want to find the y coordinate, how do you do that? If you're given any point on the curve or a straight line, and you're given the x coordinate and needed to find out the y coordinate, the best way to do that, in fact, perhaps the only way to do that, is to plug it back into the equation. Okay, then comes step 3, is to plug in the x coordinate. Okay, now it could be multiple, All right, doesn't necessarily have to be 1, but it could be multiple. Plug in the x coordinate in the equation of the curve. In the equation of the curve to find y coordinate. Okay, and again, this also could be multiple. And here also I will write value apostrophe s. Okay, now let's do a few examples to see how this really works. And then we'll see how to determine the nature of the turning point or the stationary point. So let's see what it says here. It says use differentiation to find the coordinates of the turning point of the graph y equals to f of x when a is equals to, yeah sure, go ahead, ask your question. A is equals to f of x equals to x squared minus 3x minus 5. X squared minus 3x minus 5. Okay, so here's step 1. Step 1 is that you differentiate it. So we have f prime of x, okay, which is equal to 2x minus 3. Then comes step 2, that is you set it equal to 0. 2x minus 3 equals to 0. That means 2x equals to 3, which means x is equals to 3 upon 2, which is 1.5. Okay. Now what do you have? You have the x coordinate of the turning point, but you still have to find out the y coordinate. So how do you do that? You plug 1.5 back into the original equation. Okay. And find out the x coordinate, find out the y coordinate. 3 into 1.5 minus 5. Yes, there is differentiation in IGCSE Math. So let's see what do we have. We have 1.5 squared minus 3 into 1.5 minus 5. So there you go, minus 7.25. And since we're asked to find out, since we're supposed to write it down as a point, this is how we write it. 1.5 comma minus 7.25. And there you go. That's the answer to part A. Now let's do one more question. I'm going to do part C. So in part C, we have f of x equals to 2 minus 3x minus 2x squared. So again, same way to start. You start by differentiating the equation of the curve. That means you find f prime of x, which is equal to 0 minus 3 minus 4x. Then you set it equal to 0. Minus 3 minus 4x equals to 0, which means minus 4x equals to 3, which means x is equals to minus 3 upon 4. And then you find out the y coordinate by plugging in the value of x in the equation of the curve. That means 2 minus 3 into minus 3 upon 4 minus 2 into minus 3 upon 4 squared. Okay, let's see. So what do we have? 2 minus 3 bracket open minus 3 upon 4 bracket close minus 2 bracket open fraction minus 3 upon 4 bracket close square. Okay, so what do we have? We have the y coordinate finally, which is 25 upon 8, or you can write it in decimal also, 3.125. So there you go, that's it, that's the answer, minus 3 upon 4 comma 3.125. Okay, so here's what I've done so far. We have learned how to find the turning point. Okay, but now let's see how to find the nature of the turning point. All right, so let's do that. How to find nature of turning point. Okay, now in order to find out the nature of the turning point, here's what you do. So your starting point is dy by dx. Okay, dy by dx. Now what you do is you differentiate dy by dx all over again. Now when you differentiate dy by dx all over again, what you end up with is something we call d square y over dx square. Okay, that's what we call it, d square y over dx square. Now this is also called the double derivative. Okay, now there are two possibilities. Once you've done this, there are two possibilities, and the two possibilities are fairly simple. That this could be a constant. Just a second. Yeah, so the two possibilities are that this could be a constant And constant means that this could be like a value 1, 2, 3, minus 1, minus 2, minus 3. Okay. Now, if it is a constant, then here's what you do. If it is a constant, then that means it could be positive or it could be negative. Now, if it's negative, that means it's a maximum point. That means it's something like this. This, by the way, is called a maximum point because you can see it is of maximum nature. And this, by the way, is a minimum point. Okay, as you can see, because it is of minimum nature. So as I mentioned, if it's negative, it's maximum. If it's positive, that means it's minimum. Okay. Now the other possibility is that you could end up with the double derivative that is in terms of x. Okay, and I'll explain this with the help of an example also. Now, if it is in terms of x, here's what you do. You plug in the x coordinate of the turning point. So I'll write it over here. Plug in the x coordinate of turning point. Now, if you do plug in the x coordinate of the turning point, what you end up with is a constant all over again. That means if it's positive, again, it's minimum. If it's negative, again, it's maximum. Okay. Now, this may not be 100% clear through this, whatever you want to call this, table. Okay. But let's do an example to see how it works. Okay. Now, here in this question, you can see that you're supposed to determine the nature of the turning point in question number 1. Okay. So let's do that. How do we do that? So first thing we do is we double differentiate. And by the way, keep in mind, bear in mind that if you have f prime of x, then the double derivative is going to be written as f prime prime of x. Okay, so just keep that in mind. Now, here's what happens when you double differentiate it. Bear in mind that your differential was 2x minus 3. If I differentiate it all over again, I get 2. And since this is greater than 0, that means it's minimum. And let's see what happens in part C. Here, as you can see, that f prime of x was minus 3 minus 4x. So that means if I double differentiate this, f prime prime of x, so we get minus 4. And since this is less than 0, that means it's maximum. Okay. Now, let's do a slightly more complex question to see how it works. Okay, let's do this. Is not exactly a complex question. I think I'm going to skip this question. And yeah, let's do this. Let's do this. So it says here, find the exact coordinates of the turning points on the graph y equals to f of x. Now, when it says exact coordinates, that means you're supposed to either leave it in fraction form or you're supposed to leave it in surd form. Okay, so just keep that in mind. So here's what we do. First step, we find dy by dx, which, or f prime of x, whatever you want to call it. So this is f of x or y, it doesn't matter, which is 8x squared minus 6. Now let's see. 8x squared minus 6 equals to 0. Which means 8x squared equals to 6, which means x squared equals to 6 upon 8, okay, which basically means that x is equals to plus minus square root of 6 upon 8, which you can simplify, okay, in fact, let's simplify and then write it, 6 divided by 8, 6 divided by 8, square root answer, so this can be written as plus minus square root of 3 upon 2, okay. Now, these are your x coordinates, okay? Now, let's find out the y coordinates. Yes, minus 5 will become 0. That's correct. Minus 5 will become 0. There you go. Okay, now how do you find out the y coordinate? Here's how you find out the y coordinate. So, you plug the value back into the equation. So, let's start by positive value, positive root 3 upon 4. Let's see what happens when you do that. F of positive under root 3 upon 2. Sorry, I think I said 4. I meant 2. Let's see what happens. 2 into under root 3 upon 2 cubed minus 6 into under root 3 upon 2 minus 5. Okay, so let's work this out. F of root 3 upon 2. Let's see what do we get. So 2 bracket open, make a fraction, under root 3 upon 2, close the bracket, cube the whole thing, minus 6, bracket open, make a fraction, cube root of 3 upon 2, close the bracket, minus 5. Okay, so here's what we're looking at. Minus 20 plus 9 under root 3 upon 4. And why are we writing it the way we're writing it? That's because, how did I get 8? Oh, okay, I just realized I made an error. You're right. It's not supposed to be 8, it's actually supposed to be 6. Okay, sorry about that. Let me just quickly fix this. So this becomes, sorry about that. Okay, so this becomes 6x squared minus 6. Thank you. This is what we're going to set it equal to 0. 6x squared minus 6 equals to 0, which means 6x squared equals to 6, which means x squared equals to 1, which means x equals to plus minus 1. All right, thank you so much for pointing that out. Okay, now we find out the y coordinates. Okay, so this makes it a whole lot easier. Now we don't have to deal with square root anymore. X equals to 1, x equals to minus 1. So let's see what the y coordinate is when we plug in 1. So we have 2 into 1 cubed minus 6 into 1 minus 5. Let's see. So 2 minus 6 minus 5. 2 minus 6 minus 5 is equals to minus 9. And let's find out the y coordinate here. So let's see what do we have. We have 2 into minus 1 cubed minus 6 into minus 1 minus 5. Let's see. So this becomes minus 2 plus 6 minus 5. Minus 2 plus 6 minus 5, which is minus 1. Okay, now let's write it down. 1 minus 9 and minus 1 comma minus 1. Okay, and 6. Okay, so 6, this is how I got 6. 3 into 2 is 6, and then you reduce the power by 1, and then when you differentiate minus 6x, you're just left with minus 6. Okay, so I hope that answers your question. Okay, now we're supposed to find the nature. Now how do you find out the nature? The way to find out the nature is to double differentiate it. Now notice that we have dy by dx, which is equal to 6x squared minus 6. Now if I differentiate this again, which means d square y upon dx squared, so we get 12x. Okay, now as you can see, this is in terms of x. Okay, now when you have it in terms of x, see, if you have a curve that's turning at two points, that means one point is going to be a maximum point and one point is going to be a minimum point. Okay, so we need to find out which is which. So we have two values of x. One is 1 and the other is minus 1. So one by one we're going to plug it in and see what do we get. So if you do 12 times 1, that's 12, and since this is greater than 0, that means this is a minimum point. And then if you plug in minus 1, that means 12 times minus 1, which is equal to minus 12, and since this is less than 0, that means it's maximum. Now bear in mind that there is no significance of this 12 and minus 12. Okay, the only thing that we're concerned with is the sign. Okay, is the sign that we're ending up with. Okay, now finding the equation of tangent. All right, so this is the last concept. Okay, and also pretty simple. So the way to find out the equation again through, so can you do a live of sine graphs? I've already done a few streams of sine graphs, by the way. Okay, not necessarily sine graphs, but like graphs in general. Okay, so here's how you find out the equation of any tangent. Here's x and here's y. So this is x1 and this is y1. Okay, so let's say you're given the equation of the curve, which is y is equals to f of x. Okay, so let's write it down in steps and then we'll see. Then we'll cover an example to see how it really works. Okay, now first step is this, that you find dy by dx. Okay, now once you have dy by dx, that means you can now find out the equation of tangent. And what exactly are we doing over here? We're finding out the equation of this tangent, the one in green. And the question over here is this: find the equation of tangent at x equals to x1. How do we know the nature of graph from that? Okay, you're not supposed to know the nature of graph from that. You're supposed to know the nature by taking the double derivative. Okay, and if you're given the graph, then you can just look at the shape and see what the nature is. If it's something like this, it's a maximum point. If it's something like this, it's a minimum point. Okay, that's how it works. Okay. Now step 2. Now remember, in order to find out the equation of any straight line, there are two things that we want. We want the gradient, okay, and we want a point. Then we can put it all together to find out the equation, okay. So here are two boxes that we need to check. So once you found dy by dx, the next thing you do is you plug in x1 in dy by dx. Now when you do that, what you have is the equation of tangent, the gradient of tangent. So you have the gradient of tangent line. Okay, and we can sort of put a check mark there, okay. If answer is negative, then max, and positive, then minimum. Yep, that's true. Okay, then comes step 3. Step 3 is that you plug in x1 in equation of the curve to find y1. Okay, now remember, in order to find out the equation of tangent, just knowing the x coordinate isn't enough. Okay, once you found the x coordinate, you also need to know the y coordinate. That is what will make up the entire point. Okay, so now that you have the point also, let's call it x1, y1. That means now you have sufficient information to form an equation using y equals to mx plus c. Okay, now this is something that we will cover when we're doing past paper questions. Okay, and we'll be doing those right now only, so don't worry about that. Sir, will you cover AS level P1 whole syllabus? Yeah, I'll try and cover as much syllabus as possible. Now, whether or not I'll be able to cover the whole syllabus, that's something I really can't say right now. Anyway, so as far as the concepts are concerned, this is all there is to know in differentiation. Okay, so you can see that these were all the concepts. So we've learned how to find gradient, we've learned how to find the turning point, and we've also learned how to find the nature of the turning point, and we've also learned, although we haven't done examples yet, but we've learned how to find out the equation of tangent. Okay, why don't you do SAT math? Okay, I think you've asked this question quite a few times. That's because that's not my domain. My domain is O levels and A levels math. Okay, all right, now here are all the past papers from 2020 onwards. Okay, I think you might find a few from, and this includes all the variants also. Okay, as you can see over here. Now you can download this document. If you want a fresh copy, you can download it right now. If you want the one with my solutions on it, then you can download it at the end of the stream. Okay, now here's a question. And this is from March 2022, paper 4, variant 2. Let's solve this question. Okay, and also, by the way, one thing that I want you guys to keep in mind is that you might notice that I've highlighted every question with a different color: green, yellow, blue, and I think red. Yeah, so what I've done over here is I basically tagged all the concepts. Okay, so finding dy by dx is red, finding gradient is blue, then finding the turning point and nature of turning point is green, and finding tangent is yellow. Okay, so no matter what the question is, it will always fall inside any of these 4 or 5 concepts. Okay, so yeah, just keep that in mind. Okay, so let's solve this question. Let's see what it says. It says a curve has equation so and so. The stationary points of the curve have coordinates 2, k, and so and so. Work out the value of a and the value of b and the value of k. Okay, so first thing we do is we differentiate it. So dy by dx. Okay, and when we do that, let's see, what do we get? Dy by dx is equals to 3x squared plus a. Okay, now since it's talking about stationary point, we know very well that the gradient is going to be equal to what? The gradient is going to be equal to 0. And notice that the gradient is equal to 0 when x is equal to 2. Okay, so here's what we're going to do. We're going to plug in x equals to 2, and when we do plug in x equals to 2, gradient, we know very well, is going to be equal to 0. And it's not just going to be equal to 0 at x equals to 2, it's also going to be equal to 0 when x is equals to minus 2. Okay, so notice what happens when we do that. So 3 into 2 square plus a, this is equal to 0. So 12 plus a equals to 0, which means a is equals to minus 12. So what we have now is the value of a. Okay, now let's find out the value of b. So once we have the value of a, notice that our equation looks like this. Our equation looks like y equals to x cubed plus, minus 12x plus b. Okay, thank you. Okay, now the next thing we need to do is we need to find out the value of k. Now how to do that? Let's see. Now in order to find out the value of k, we're gonna have to make use of these equations. Yes, Hamza, I will do that. No need to spam. Okay, I'm sorry, I'm gonna have to hide you. Okay, so here's what we're gonna do. We're gonna plug in x as 2 and set it equal to k. Let's see. So this is the point that we're plugging in, 2 comma k. So we plug in x as 2 cube minus 12 into 2 plus b. Okay, so we have k is equals to 8 minus 24 plus b. Okay, that means k is equals to minus 16 plus b. Okay, so this is one equation. All right, and we're going to leave it over here. Now we need to form another equation, and we're going to do that with the help of this set of points. So we have the equation of the curve y equals to x cubed minus 12x plus b. Okay, now the point that we're plugging in is this, minus 2 into comma 10 minus k. So 10 minus k in place of y, in place of x, we plug in minus 2. So minus 2 cubed minus 12 into minus 2 plus b. Let me just make sure I haven't made a calculation error. Yeah, that's correct. Okay, so we have 10 minus k, which is equal to minus 8 plus 24 plus b. Okay, so 10 minus k equals to 16 plus b. So here, if I make k the subject, so that means 10 minus 16 is minus 6 minus b equals to k. So here's what I've done. I've taken 16 over to the left hand side and b over to the left hand side also. Okay, now notice that they're both equal to k. That means we can equate the two. So if I equate the two, we have minus 16 plus b equals to minus 6 minus b, and then we can solve this. Let's see, what do we get? We get 2b, which is equal to minus 6 plus 16, that means 10, and now we have the value of b, which is equal to 5, and that is the correct answer. Okay, now we can find out the value of k. So k is equals to minus 16 plus b, that means k is equals to minus 16 plus 5, which means k is equals to minus 11, and there you go, that's your answer. A is minus 12, b is 5, and k is minus 11. So this was a 6-mark question. That means it did require a decent amount of working. Okay, all right, now here's another question which I'm going to solve. Let's see what this says. It says a curve has equation y equals to x cubed minus 3x plus 4. Work out the coordinates of the two stationary points. So first things first, we differentiate it. That means this becomes 3x squared minus 3. We set it equal to 0. 3x squared minus 3 equals to 0, which means 3x squared equals to 3, which means x squared equals to 1, which means that x is equals to plus and minus 1. Okay, now that you have the coordinates of x, you still need to find out the coordinate of y, and you can do that by simply plugging in the value of x back into the equation of the curve. So let's see what happens when x is 1. Y is equals to 1 cubed minus 3 into 1 plus 4. So y is equals to 1 plus 4, which is 5. 5 minus 3 is 2. There you go. And let's see what happens when x is minus 1. So y is equals to minus 1 cubed minus 3 into minus 1 plus 4. So that's 3 plus 4, 7. 7 minus 1 is 6. And there you go. That's it. That's your answer. Okay, determine whether each stationary point is a maximum or a minimum. Okay, so for that, we have dy by dx, which was equal to 3x squared minus 3. Now we further differentiate it, which means d squared y upon dx squared, which is equal to 6x. Now we have, since we have two different turning points, so one by one we plug in the values. So we plug in x equals to 1, and then we plug in x equals to minus 1. When you plug in x equals to 1, 6 times 1 is equals to 6, which is greater than 0. That means it's minimum. And then when you plug in x as minus 1, that means 6 into minus 1 is minus 6, which means that this is equal to, this is maximum. Okay, now, and I just realized I've written the incorrect answer here. This is no, wait, it's correct. Never mind, it's correct. Okay, all right, now I'm going to skip a few questions. Okay, and I'm going to jump straight to equation of tangent here. Okay, because it's not frequently tested. Okay, here we go. It says find the equation of the tangent to the graph y equals to x cubed minus 4x squared plus 4x at x equals to 4. Now remember, here's the first step. and that is you find dy by dx, which is equal to 3x squared minus 8x plus 4. Okay, the next step is that you plug in x equals to 4 to find out the equation, the gradient of tangent. So 3 into 4 squared minus 8 into 4 plus 4. So let's see what do we get. Dy by dx equals to 16. 16 into 3 is 54. Wait, is it 54? 48, sorry, 648 minus 32 plus 4. So we get 20. Now this 20 is the gradient of tangent. Okay, remember this is the gradient of tangent. So after this, our equation looks like this. Y is equals to 20x plus c. Now we still need a point through which the line is passing. Now we have the x coordinate, but we still need to find out the y coordinate. Okay, now in order to do that, we go back to the equation of the curve and we plug in the value of x. The equation of the curve is y equals to x cubed minus 4x squared plus 4x. So we plug in the x coordinate, which is 4. 4 cubed minus 4 into 4 squared plus 4 into 4. So 4 cubed and minus 4 into 4 squared are as good as 4 cubed minus 4 cubed. So you get the y coordinate, which is 16. So that means now you have enough information to find out the y coordinate also. So 20 is equals to 20 times 4 plus c. That means 20 is equals to, sorry, not 20, 16. 16 is 20 into 4 is 80 plus c. And let's see what do we get. Okay, let me just quickly check. So we get 16 minus 80, which is equal to c. What 16 minus 80 is 64. So c is minus 64. And there you go. Now we have completed the equation of tangent. So 20x minus 64. And is that the correct answer? Yep, that's the correct answer. Okay. Now that's pretty much all there is as far as the concepts are concerned. Okay. I will encourage you guys to complete this worksheet. Okay. And yeah, that's about it. I've written the answers over here so you guys can check your answers once you're done. And that's it. That's it from my side. I am going to stop here. And I'll see you guys in the next stream. Let me know. I'll post on my Instagram as to what I should stream next. Please let me know then. And yeah, that's it. I will see you guys in the next stream, inshallah. Take care, everyone. Allah Hafiz. And yes, Balaj, I just saw your question. You can use AdMath log videos for A-Level P3. You can totally do that. Okay. Okay, so yeah.